the strangest exoplanet we have ever discovered. 63 light-years from Earth, in a quiet corner of the constellation Vulpecula, the Little Fox, there is a planet that from a distance looks almost exactly like home. It glows a deep, brilliant blue. The same shade of blue that has meant one single thing to us for the entire history of our species. Water, oceans, life. For one brief moment, when astronomers first measured its color, it looked like hope, a blue marble hanging alone in the dark, 63 light-years away. But that blue is not water. That blue is a lie, because on this world, it rains glass, sideways, in winds that move 7 times faster than the speed of sound. This is the story of the strangest planet we have ever found, and how the most hostile world in the galaxy quietly taught us how to search for life itself. Before we go any further, if you find the search for other worlds as fascinating as I do, take 1 second to subscribe. This channel is dedicated to the strangest, most beautiful, and most unsettling discoveries in the hunt for life beyond Earth, and you are not going to want to miss what is coming. Now, let's talk about the blue planet that isn't what it seems. For as long as human beings have looked up at the night sky, we have been asking the same quiet question: are we alone? And somewhere along the way, we decided how we were going to try to answer it. We would look for blue. Blue is the color of Earth. When the Voyager spacecraft turned its camera around and photographed our planet from billions of miles away, we appeared as a single pale blue dot, suspended in a sunbeam. That blue is water, and water is the one ingredient that every living thing we have ever known absolutely depends on. So when we began building telescopes powerful enough to study planets around other stars, we had a plan. Find another blue dot. Find another ocean world. Find another Earth. You have to understand just how new all of this really is. For almost the entire history of astronomy, we did not know for certain that any planets existed beyond our own solar system. We assumed they were out there, but we had never actually seen one. That changed in 1995, when astronomers confirmed the very first planet orbiting another sun-like star. And suddenly, the floodgates opened. World after world began to appear, each one a little stranger than the last, each one forcing us to stretch our idea of what a planet could even be. And within just 10 years of that first discovery, we stumbled straight into one of the strangest of them all. Because in the constellation Vulpecula, we thought for one glorious moment that we had found exactly what we were looking for. The planet is called HD 189733b. It is not a poetic name. It is a catalog entry, a plain string of numbers assigned to a star and the world that circles it. But this ordinary catalog entry would go on to become one of the most studied, most photographed, and most bizarre planets in the entire history of astronomy. Here is how we found it. In 2005, astronomers were watching a star roughly 63 light-years away. They were not looking directly at the star, hoping to see a planet beside it. You cannot simply point a telescope at a distant star and spot a planet next to it. The star is billions of times brighter. It would be like trying to see a single firefly sitting on a stadium floodlight from across an entire ocean. So instead, they watched the starlight for a flicker. Every 2.2 days, the light from this star dipped ever so slightly. Not nearly enough for the human eye to ever notice, but precise instruments caught it. Something was passing in front of the star, blocking a tiny fraction of its light, and then moving on. That something was a planet, crossing the face of its star on a regular, predictable schedule. Astronomers call this the transit method, and it has become one of our most powerful tools for finding new worlds. From the exact amount of light the planet blocked, they could calculate its size. And what they found was enormous. HD 189733b is a gas giant, larger than Jupiter, the biggest planet in our own solar system. It carries more than 100 times the mass of Earth. This was no small rocky world. This was a giant. But the size was not the strange part. The strange part was where it lived. Jupiter in our solar system sits very far from the Sun. It takes about 12 years to complete a single orbit. HD 189733b completes an entire orbit of its star in just over 2 days. Think about that for a second. A year on this planet, the time it takes to travel all the way around its star, is shorter than a long weekend. That is how impossibly close it sits to its star. If you took Jupiter and dragged it inward until it was almost touching the Sun, you would have something like HD 189733b. Astronomers call these worlds hot Jupiters, and when we first started finding them, they broke almost everything we thought we knew about how solar systems are supposed to work. Because a gas giant is not supposed to be able to form that close to a star. The heat and the radiation should tear the raw material apart long before it can ever gather into a planet. And yet, there it was, a massive world orbiting so close that its star swallows a huge portion of its sky, bombarding it with radiation every second of every single day. At that distance, the planet is tidally locked. That means one side of the planet permanently faces the star, trapped in eternal, blistering daylight. The other side is turned forever toward empty space, locked in perpetual night. There is no sunrise on HD 189733b. There is no sunset. There is only the day side that never ends, and the night side that never begins. The temperature on the day side climbs to over 1,000 degrees Celsius. That is hot enough to melt silver, gold, and aluminum. And this is where the story starts to get truly strange. And there is another detail about this system that makes it stranger still. The star that HD 189733b orbits is not alone. It has a companion, a small, dim red dwarf bound to it by gravity, drifting through space beside it. So this planet does not have one sun in its sky. It has two. One is a blazing orange star, enormous and close, dominating everything. The other is a distant red ember, brighter than any star in Earth's night sky, but still just a cold point of light, far off in the black. Two suns over a world where it rains glass. It sounds like something ripped from science fiction, except this one is real, and we have measured every part of it. For years, we knew the planet's size, its orbit, and its temperature, but we still did not know what it actually looked like. What color was it? For a planet 63 light-years away, orbiting right beside a blinding star, that seemed like an impossible question to answer. In 2013, using the Hubble Space Telescope, astronomers finally cracked it. They watched the planet as it slipped behind its star, a moment called a secondary eclipse. Just before the planet vanished, they measured the combined light of the star and the planet together. Then, when the planet disappeared fully behind the star, they measured the light of the star all by itself. The difference between those two measurements was the light reflecting off the planet. And when they analyzed that reflected light, they found it. A deep, rich cobalt blue. The exact color of a clear ocean seen from orbit. The exact color we had been quietly searching the whole galaxy to find. For the search for life, this should have been a triumph. A blue world, the color of water, the color of home. But the scientists studying it knew instantly that something was terribly wrong. Because this planet was over 1,000 degrees. There could be no oceans here. There could be no liquid water of any kind. So why on earth was it blue? The answer is one of the most unsettling things we have ever discovered about another world. On Earth, our sky is blue because molecules in our air scatter the blue light coming from the sun. The blue of HD 189733b works on a similar principle, but the particles doing the scattering are not gentle molecules of air. They are particles of silicate. Silicate is the material that makes up sand and rock, and it is also the exact material that makes up glass. In the crushing heat of this planet's atmosphere, silicate does not stay solid. It boils away into vapor. Then, high up in the atmosphere where it is slightly cooler, that vapor condenses back into tiny particles. Clouds. But not clouds of water, clouds of glass. And these microscopic grains of glass are what scatter the starlight and give the planet its beautiful, deceptive blue. But the glass does not simply hang there quietly. This planet has weather, and the weather on HD 189733b is the most violent we have ever recorded anywhere in the known universe. The winds tear across the atmosphere at speeds reaching 540 miles per hour. To put that in perspective, the strongest hurricane ever recorded on Earth carried winds of around 200 miles per hour. The winds on this planet are more than 25 times stronger than that. They move at roughly 7 times the speed of sound. Now combine those two facts together. The atmosphere is full of tiny particles of glass. The wind is howling at 7 times the speed of sound. What you get is rain. Rain, made of molten glass, driven not gently downward, but sideways, blasted across the planet at supersonic speed. If you could somehow stand on this world And you absolutely could not. You would be sandblasted by a storm of glass moving faster than a rifle bullet in temperatures that would vaporize you long before a single shard ever reached you. In fact, HD 189733b holds yet another quiet record. It was one of the very first planets beyond our solar system to have an actual map made of it. Not a photograph, but a temperature map showing how heat moves across the whole planet. And that map revealed something fascinating. The hottest point on the planet is not directly beneath the star, where you would naturally expect it to be. It is shifted off to one side. And the reason is those monstrous winds. They are so powerful that they physically drag the heat of the day side around the planet before it can radiate away, smearing warmth toward the night side and shoving the hottest spot off-center. We are watching an entire planet's climate being rearranged by wind from 63 light-years away. Try to actually picture standing there for a moment. You are on the day side, though of course there is no solid ground beneath your feet, only deeper and deeper layers of scorching gas. Above you, an orange star fills a quarter of the sky, far larger than our sun ever appears from Earth. The air itself seems to glow. There is no blue sky and no soft white clouds, only a churning haze shot through with the shimmer of vaporized rock. And driving through all of it, faster than any sound, comes that endless horizontal storm of glass. There is no shelter anywhere. There is no night to bring relief on this side, because here, the day simply never ends. This is not a place life could cling to. This is a place that would erase every trace of it in seconds. This is the blue planet. This is the world that, from a distance, looked like it just might be home. And yet, this is exactly where the story turns from pure horror into something genuinely, surprisingly hopeful. Because HD 189733b, for all of its violence, became the single most important teacher in our entire search for life. Here is why. When that planet passes in front of its star, not all of the starlight simply gets blocked. A small amount of it passes straight through the thin outer layer of the planet's atmosphere on its way to us. And when light passes through a gas, that gas absorbs very specific colors. Every molecule, whether it is water, methane, or carbon dioxide, leaves its own unique fingerprint stamped into the light. It is like a chemical barcode written directly into starlight. By carefully studying the starlight that filtered through the atmosphere of HD 189733b, astronomers were able to do something that had never truly been done before. They read the actual ingredients of an alien atmosphere from 63 light-years away. To really appreciate why that mattered so much, remember the problem we started with. These planets are impossibly far away, and drowned in the glare of their stars. We cannot fly to them. We cannot land on them. For most of human history, the idea of knowing what the air of another planet was made of would have sounded like pure fantasy. And yet here we were, sorting the individual molecules of a world so distant that its light takes 63 years just to reach us. HD 189733b proved it could be done. It turned atmospheric science from a dream into a repeatable measurement. And once something becomes a repeatable measurement, you can start doing it to every single world you find. And what did they find in that alien air? They found water, actual water vapor, detected in the atmosphere of a planet, around another star. They found carbon dioxide, one of the same gases that blankets our own planet. And they found something even more striking, a discovery that would rewrite what we believed was possible to measure at all. In 2008, astronomers announced that they had detected methane in the atmosphere of HD 189733b. Methane is an organic molecule. On Earth, a great deal of our methane is produced by living things. Now, to be clear, on a 1,000-degree furnace of a planet, methane means absolutely nothing about biology. It formed there through ordinary chemistry, not life. But the detection itself was historic. It was the very first time an organic molecule had ever been identified in the atmosphere of a planet beyond our solar system. For the first time ever, we had proof that the building block chemistry of life could be found and measured on alien worlds. The tools worked exactly as we had hoped. The old dream of reading the skies of alien worlds finally had real teeth. Because remember, none of this means life exists on HD 189733b. The planet is a 1,000-degree hurricane of glass. Nothing survives there, and nothing ever truly could. But the technique, the ability to read an atmosphere just by watching starlight pass through it, is the exact same tool we now use to hunt for living worlds. This planet was the proving ground. It was where we first learned to read the very air of distant planets, and that skill is now being pointed at smaller, cooler, rocky worlds where the same chemistry might actually mean everything. The planet's story grows even more dramatic when you turn your attention to its star. HD 189733b orbits so close to its sun that it is constantly under attack. The star regularly erupts with powerful flares, blasting the planet with X-rays and ultraviolet radiation. Astronomers have actually watched these flares slam into the planet and observed its atmosphere reacting in real time. The upper atmosphere heats up, swells outward, and enormous amounts of gas are torn off and lost to space. Some studies suggest this planet may be shedding thousands of tons of its atmosphere every single second. In a slow and violent way, it is evaporating. The star is quite literally eating its own planet, one flare at a time. Over billions of years, worlds like this one can be stripped down to a fraction of their original size or destroyed entirely. This too teaches us something absolutely vital. It shows us how a star can slowly sterilize and erode the worlds circling it. When we search for habitable planets, we are not only looking for the right distance from a star. We are looking for stars calm enough to let an atmosphere survive in the first place. A violent, flaring star can leave a perfectly positioned planet completely dead. HD 189733b is the extreme example that proves the rule, and we have watched a gentler version of this exact story play out much closer to home. Mars was once a warmer, wetter world, with rivers and possibly even shallow seas, but Mars is small, and its protective magnetic shield faded away, and over billions of years the solar wind slowly stripped its atmosphere off until it became the cold, thin, dusty desert we see today. Earth survived because it held on to its magnetic field and sits at a safe distance from a stable, well-behaved star. HD 189733b shows us that same story written in the extreme, turned up to maximum volume. It is a stark reminder that a planet's fate is never decided by the planet alone. It is a constant negotiation between a world and the star it is chained to. So step back for a moment and really think about everything this one strange planet has given us. When we first measured its color, we thought we might have found a cousin of Earth, a blue world glowing softly in the dark. Instead, we found the exact opposite of a habitable planet, a place where it rains glass sideways at supersonic speeds, where the temperature melts metal, where a furious star is slowly tearing the atmosphere away into the void. But in studying that hostile world, we learned nearly everything we now know about how to actually search for life. We learned that color alone means nothing. A planet can shine blue for reasons that have nothing whatsoever to do with water. We learned how to read an atmosphere from clear across the galaxy, one molecule at a time. We learned how to measure the danger posed by a planet's own star. Every one of those hard lessons is now built directly into the way we hunt for genuinely habitable worlds. This is the strange irony sitting right at the heart of the search for life. Some of our most important progress has come not from finding paradise, but from studying hell. The James Webb Space Telescope, the most powerful observatory humanity has ever built, uses these exact techniques right now to study the atmospheres of small rocky planets, searching for the same chemical fingerprints that HD 189733b first taught us how to read. Every single time we point that telescope at a distant world and ask whether it could support life, we are quietly using lessons written in the glass rain of a planet 63 light-years away. In a very real sense, HD 189733b has become a permanent reference point for the entire field. When astronomers develop a new instrument or a new method for studying alien atmospheres, this is one of the very first worlds they test it on, precisely because we now understand it so well. It has been observed again and again across more than a decade by nearly every major space telescope we have ever flown. A planet that once looked like a lucky accident of discovery has quietly turned into a permanent laboratory in the sky, a place we return to whenever we want to sharpen the very tools that will one day be aimed at a true second Earth. There are now thousands of confirmed planets sitting in our catalogs, more than 5,000 of them and still counting. And yet this single blue giant remains one of the most valuable of them all. Not because it could ever host life, but because it patiently taught us how to look for it. Now, you might reasonably wonder how we can crown any single planet the strangest, when the galaxy is absolutely full of bizarre worlds. There are planets denser than iron and planets lighter than foam. There are worlds where the temperature runs so high that the sky itself glows, and worlds that have been flung out of their systems entirely, drifting alone through the dark with no star at all. But HD 189733b earns its place at the very top for one particular reason. It is not just strange. It is strange while pretending to be familiar. It wears the exact color we spent decades searching for, the color that was supposed to mean home, and hidden underneath that gentle disguise is one of the most lethal environments ever measured. It is a wolf wearing the clothing of the one single thing we most desperately wanted to find out there. For thousands of years, we looked up at the stars and imagined the worlds that might circle them. We pictured oceans, forests, other Earths, other homes, waiting patiently for us in the dark. And when we finally built the tools to truly look, one of the very first strange worlds we found shattered that simple dream and replaced it with something far stranger and far more beautiful. A planet the color of the sea, where the rain is made of glass and the wind could tear a mountain to dust. The universe is under no obligation to match our imagination. It is almost always stranger than we expect it to be, and every strange world we find, no matter how hostile, brings us one step closer to answering the oldest question we have ever asked. And that quietly changes how it feels to look up at night. Every one of those points of light could have worlds circling it. And if HD 189733b has taught us anything, it is that those worlds will not be the tidy, familiar places we once imagined. Some will be frozen solid. Some will be drowned in lava. Some, like this one, will be beautiful and deadly at the very same time. But hidden somewhere in that vast catalog of strange and hostile places, there may be a small handful of quiet, temperate blue worlds where the chemistry lines up just right. Finding those is the whole point. And the strangest planets are the ones showing us how. We are still out there looking for that other blue dot. The true one. The one where the blue really is an ocean, and the ocean is really full of life. And thanks in part to a hell world named HD 189733b, we finally know how to recognize it when we find it. If you enjoyed this journey across the galaxy, do me a quick favor and tap that like button. It genuinely helps this channel reach more curious minds like yours. And make sure you are subscribed, because in the next video, we are traveling to a world where the ground itself may be made of diamond. A planet so dense and so strange that it forced scientists to completely rewrite what a planet can even be made of. You are not going to want to miss it.